Thanks for doing that. Appreciate it. Okay. All right. So, guys, more probability here. We'll start looking at 5.2. Hopefully, we'll get a chance to look at 5.3 tomorrow. Maybe a short quiz here towards the end of the week, around Friday or so. We'll see how much we get done today and kind of let that determine where we're at the end of the week. But kids, independent and dependent events. Okay? What's the difference between the word independent and dependent? Or the words independent and dependent?
Dependent counts on something, independent doesn't matter.
Okay, dependent counts, it matters. It say that again. How'd you say it again, Jacob?
When it's dependent, it like counts on something and needs something else to
Okay, it
make
needs something else to have happened, right? Okay, this has to happen before you can consider this. So dependent means it depends on this. So how many of you guys have answered a question ever posed to you by say, well, it depends on blah, blah, blah. Is it? Anybody ever answered a question like that?
Yeah.
Well, it depends if I have basketball practice or not. That'll determine if I can go, okay? So dependent means we've got to have something happen first before we can look at it. Independent means it's on its own. It can happen anytime, okay? So we're going to look at that as it relates to probability today. So in 5.2 about independent and dependent events, how about our question we're trying to answer? Who wants to read that for me?
I need to determine whether two events are independent or dependent.
Okay, how do you determine if stuff is independent or dependent? So, goals to help us answer that question. We need to determine, first of all, whether events are independent events, find the probabilities of independent and dependent events, and then we're going to look at what's called a conditional probability. Okay, probability given a certain condition. We might say, what's the probability this happens given you rolled a 6 or something like that. All right? All right, so independent events. How about a volunteer to read independent events for me? Go ahead, Michael.
Two events are independent events when the occurrence of one event does not affect the occurrence of the other event.
Okay, so the outcome of one event does not affect the other outcome. Okay? It's like flipping a coin and rolling a die. If I flip a coin, does that have any bearing on the rolling of the die?
No.
No. Okay? Okay, you're going to see stuff in terms of independent events written like this today. It's going to say the probability of A and B, like so. When you see stuff for independent events like this, when it says probability of what's the probability of A happening and B happening, this is just simply going to be the probability of A times the probability of B. And I think I've got that listed somewhere else in here, okay? Then kids, dependent probability. Somebody want to read the dependent probability? Go ahead, bud.
Who, me?
Yep.
Oh, okay. Two events are dependent events when the occurrence of one event does not affect the occurrence of the other event.
Okay, so two events are dependent events when the occurrence of one event does, keyword does affect it, okay?
Does not.
So the other one up here is does not affect it. So we would say, what's the probability of A and B happening? This is the notation you're going to see when I ask about the probability in A and B of dependent events. You're going to see it written as the probability of A times the probability, this is how you read this. This is written as probability of B given that what's already happened. A. So make sure we understand how to read this. This is written as the probability of event A happening times the probability of event B happening given what already?
Is that a line?
That's a straight up and down line. Yep. It's just like a wall there. Okay? No, not a Donald Trump question. Let's not bring that word up in this classroom, please. Thank you. All right. Guess you know where I stand.
I don't stand anywhere.
Anyway,
Donald
this
Trump,
math
you
looks
think
pretty
he's
good.
the best president we've ever had? That's what I'm getting from this.
Considering
Can we not go
15,000
through
people he
today?
just laid off at GM because his tariffs are too high. Yeah, that auto industry that Obama saved. Yeah, that one. Yep. All right. Don't get me going because you'll lose. All right. Next term up there. What's next term?
Conditional
This is going to be really important today to talk about. Conditional probability. This is going to be pretty important today. Okay. Conditional probability is a lot like dependent events. It says the probability that event B occurs given that event A has what, kid? Occurred is called the conditional probability. And we just kind of talked about this. This is the probability of B given what, kids? Is written as P, the probability of B, and then it's at /A. So this is a conditional probability. It says, oops, didn't want to do that. This is the probability that B is going to happen given what already happened, kids. A, okay? So the probability of B happening given that A has happened already. All right, so that's going to be a term that we need to know. And then two other things that we should know already, kids, in terms of our previous section. We already know what probability is. Probability is the extent to which an event is likely to occur, measured by the ratio of favorable cases to the whole number of cases. And then sample space. Sample space is the total number of what again, kids?
Outcome.
Sample space is the total number of outcomes. Like when we had that game that he asked about in number 7, we could either win or lose, so there was 2 outcomes each day, but we took that over 5 days, so how many possible outcomes were there, winning and losing? Well, we said 2 times 2 times 2 times 2 times 2, which was 32 possible ways. So these are reviews right here, so I don't need to put anything in here, all right? So let's get started here. Vocab-wise, we should be in pretty good shape. Core concept. Volunteer to read core concept for me. Yes, Michael.
Probability of independent events, words to events, A and B are independent events if and only if the probability that both events occur is the product of the probabilities of the events.
Okay. When events are independent of each other, meaning one doesn't depend upon the other, this is what you really need to know. Okay? The probability of the 2 events happening are just the products of each other. So, in example 1, determining whether events are independent or not. Okay? Example 1 says a bag contains 6 pieces of paper numbered 1 through what, kids?
6.
A student randomly selects a piece of paper and then does what?
Not replace it.
This one is
Oh, I'm on the wrong one.
actually replaces it there in
Yeah.
example 1. Okay, so we're saying, well, you're just going to replace it there. So each time, every time I grab a number out of that bag, how many choices are there every single time?
Wait, 6.
6 of them, okay? All right, so it says we randomly select another piece of paper. It says use a sample space to determine whether randomly selecting a 5 first and randomly selecting an odd number second are independent events. Well, what do we have to have happen first? What are we selecting first, kids? 5. So event A is like selecting a 5. Okay? Event A is selecting a 5. Now kids, what kind of number is 5? Odd or even? Now if I kept the 5 out of there, would that change the probability that I get an odd? Yes, because if I keep it out of there, it changes that. But if I replace it and put it back in there, does that change the probability on the second part that we draw an odd number? No. So replacing it. So are these events, does event A impact event B where event B is selecting an odd? Guys, in other words, is B dependent upon A?
No.
If I replace the 5? No. Okay, so are these independent or dependent events? They're going to be independent of each other because every single time there's always how many numbers in there? Every time you draw, there's always going to be 6 numbers in. Now, if I didn't replace it, if I didn't replace that 5, would that impact the chances that we draw an odd number then?
Yeah.
Yes. And those would be what kind of events? Okay, so I'm going to make a note right here. Since we replace after each draw, what kind of events are these? We have independent events. Okay, so it says use a sample space to determine whether randomly selecting a 5 first and randomly selecting an odd number are independent events. The answer is no, because you're going to replace it anyway. Okay, You guys okay with that? All right. Now, if it said you're not replacing, then what kind of event would it have been? Dependent, because it depends on what you drew out the first time in order for that second event to happen.
Hey, that's number 2.
Okay, so let's talk about example 2, determining whether events are independent or not. It says a bag contains 6 pieces of paper this time, numbered 1 through 6. Same example. A student randomly selects a piece of paper, but what, kids? Does not replace it. Right? And then randomly selects another piece of paper. Use a sample space to determine whether randomly selecting an even number first and randomly selecting a 4 second are independent. What's probability A? What's the event A, kids? Okay, you're going to select a what? An even number here, right? Okay, that even number could be a what? Could be a 4, right? Okay, and then the event B is going to be drawing a. Okay, so if I had cards numbered, this says number 1.
Draw a 4.
This is number 2. This is number 3. This is number 4. This is number 5.
What about 7, 8, 9?
Well, we're only going 1 through 6 up there according to the directions, right? Is that correct? Okay. Let me ask this question. I'm going to come up here at random and draw a card. Ready for this? Probability that I draw what first?
Just look down and see.
I'm going for a
Well, they're in
4.
order,
Draw
so.
4.
Draw an even, right?
Yeah.
Okay, now does drawing an even impact drawing a 4 on the next one possibly?
Maybe.
Does the probability of getting a 4 now after I pull the card out of here change after I've taken that first one?
Yeah.
Yeah, because what could have happened on that first draw?
You could have picked 4.
Okay, right now it's 4 drawn.
No.
No, and without replacing it, that changes the probability. So how about this? What happens if I took the 4 right here?
Then it makes
Then you
probability
took-
terrible.
Well, then you can identify
Right.
probability.
But does that change the probability depending upon what happened here first if I don't replace it?
Sure.
Okay, so what kind of events are these? Dependent. So when you are starting not to replace stuff, well, the probability that this event happens is going to depend on what already happened, okay? So the probability, I'm just going to say here, the probability of B happening depends on what happened in probability A, didn't it? Okay. How come probability B didn't depend on probability A in example 1?
Because they replaced it.
Yeah, we replaced it. I mean, you had the same sample space to choose from. You had the same exact sample space to choose from after you replaced what you already took out. Okay? So changing sample spaces. Here, example 1. I'm taking a 4. I got it. But I'm going to put it back now. What's the probability I draw? Is it going to be exactly the same again since I replaced it or different? Exactly the same. Okay? But now this time I'm going to say, I drew. Now the next event to happen depends on what I already took because you're not going to do what here?
Get what you already
You're
have.
not going to replace this. Okay? What do you guys think? Understand the difference between dependent and independent?
Right.
Let me ask this question. If I flip a coin and then roll a die, does the outcome on the die depend upon what you flip for a coin? No. The outcome on the die has no dependency on flipping that coin. So we would say they're independent events. Okay? All right, let's take a look at the next page then, kids. Let's move. Another core concept up here. It's good stuff.
There's a lot of core concepts.
There are. It's important stuff. Okay, the probability of what, kids?
Dependent
In
events.
words, says if 2 events, A and B, are, what's the word here, kids?
Dependent event.
Then the probability that both events occur is the product of the first event and the conditional probability of the second event. In symbols, we say, you know what? The probability of A and B, understanding that they're dependent events, and we wrote this in the vocab, is the probability of A happening times the probability of B given what happened already. What event? This is written as the probability of B given what happened already. A. So let's look at some examples. Example 3, finding a probability of, in this case, independent events. Oh, I need to come up with a spinner. Let me look here. The spinner has, let me put a spinner up here. Hang on a second.
Spin the spinner.
I'm going to put some numbers to this. Gallery, mathematics, probability and statistics, multimedia, spinner, and we need to change some settings on this. Let me do that. Okay, here's my spinner. I'm gonna put some numbers to this. Okay, you ready?
Can I go to the bathroom first?
Sure. Okay, I need to put numbers on here, so give me a second to do that. I want to name this to be a 1. Oops. I want this to be a 1, a 2, a 3, a 4, a 5, a 6, a 7. Whoops. What do you think we're going to call that last sector? That last sector is number 8, kids. All right. So here's an example. Example 3 says, finding the probability of independent events. It says use the spinner in example 3. That's the spinner that they provided. It says find the probability that you get an even number first, and then a number less than 3 on your second spin. Okay? What are we trying to have happen first? Trying to have an even number happen first. So event A, whoops, I needed. Event A, the probability of A happening is equal to, what's the probability of getting an even number on the first spin, kids? Well, how many numbers are even up here?
4 out of 8.
4 out of 8. So the probability of A is the probability of an even number, and that's going to be equal to 4 out of 8. Or some of you might right off the bat reduce that to
2 out of 4,
1/2, right? So that's the first event. Now, event B. Does spinning and even have any impact on the next thing that's going to happen? Event B. First spin, we're trying to spin what? Even. What are we trying to do on the second spin?
number less than
Less than 3, and number less than 3. Does that first spin have any impact on that second spin? Absolutely not. So what's the probability we get a number less than 3? Well, what numbers are less than 3 up there, kids? 2 and 1. So the probability that we get a number less than 3 is equal to, you said 2 out of 8, right? 2 out of 8, which we reduced to what here? Okay. Well, since these probabilities are, what I would say are independent of each other, the probability of that event happening in that order, the probability of getting even first, and then the probability of being a number less than 3 would be the product of 1/2 and 1/4. So up here I'm going to write the probability of A and B happening, or the probability of getting an even first, and then a number less than 3. Whoops. Probability of that would be, what's 1/2 times 1/4, kids?
Okay, I got it. 1/12.
Close.
Oh my gosh, 1/2 times. Oh my gosh, I'm sorry.
That's okay.
It's 1/8.
1/8. Okay. It's okay to make mistakes in here. I do it every day. Be 1/8.
In fact, greater than sign. It's supposed to be less than.
It's like my mind.
Well, I didn't catch that last part, Jacob.
In
What
fact,
did you say?
greater than sign is supposed to be less than sign.
Yeah, you're right. That should be a less than sign. Thank you.
There we go. Now we're even.
Okay. I'm not gonna apologize for mistakes. So I make them every day. Yeah, it should be less than 3 up there. All right. So I'm gonna go back, and this is all gonna go away here in a second. Do you guys have what you need?
Sure.
Okay, well, now I'll rewrite this real quickly, so hang out here with me. So right here, what was the probability that we were going to get an even number, kids, on that first spin? And then the probability that we got a number less than 3 was 1/4. So the probability of these two events happening, since they're independent, the probability would just be 1/2 times 1/4, which is, in that order, there's a 1 out of 8 chance that that's going to happen. Okay? By the way, let's see if we can do it quickly. If I do it, this was 1, 2, 3, 4, 5, 6, 7, and 8. What do we have to get first? Oh, got the even. Now I need to get a what or a what, kids? 1 or a 2. If I get this, you all owe me a bag of Sour Patch Kids.
No, I'm
It's
out.
only a 1 in 8 chance. So.
Well, now I've got a 1/4 chance now,
Yeah.
don't I? Because this has already happened, right? So this is like,
Yeah. So it's almost like it's dependent, but it's not.
well, kind of is now because,
No, that's, yeah.
come on, come on, come on. White or red, white or red, white or red. Come on, baby. Dang it, it didn't work. Okay. Well, all right. I'll try again tomorrow. Okay, are you guys okay with that example right there? All right, very good. So let me move this out of the way here quickly. Let's run into example 4 here. Probability of dependent events here. Okay, so this one here, so the second event's going to depend on what happened in the first event. Okay, so 9 women and what?
6 minutes.
Are on a committee. 2 people are randomly chosen from the committee members to serve as a chairperson and a treasurer. Find the probability that both events A and B will occur. Okay? So event A, the chairperson is what, kids? Okay? How many people are up here totally? Okay. So event A right here, kids. There's 15 people up here. 9 women. And what? Means that there are 15 total people, right? Okay, the order they want this to happen is the probability events A and B occur. All right? Well, event A here, kids, event A here real quickly says, well,
Looking through my stuff.
first thing that we're going to choose is a chairperson to be a what, kids? Okay, what's the probability, given all the people that are up there, the first thing that we do is choose a man.
Yeah, 6 out of 15.
6 out of 15. Right? But event B then says the next chairperson is now a woman. Guys, here's the deal. How many people were standing up here when they chose them?
15.
15. And of the 15, 1 man did what? In event A.
So there's 14.
So the first person to walk out was a man. So now how many people are left up there?
14.
Of which, how many of those 14 left are still women?
9.
Okay, so the chairperson in event B is a woman. What's the probability that that's going to happen? 9 out of 14. Okay? This is the probability of event A happening right
Better
here.
odds.
Okay? But this over here is not the probability of event B happening. This is a probability that event B happens given what already happened. This here depends on what happened over here. So this here is now a probability of B given A happened already. So is this an example of dependent or independent events? This is dependent. And then to find the probability that this happens right here in this order, so I'm going to say the probability of A and B in this case would equal 6 over 15 times what, kids? 9 out of 14. Whoops, didn't want to put that sign there. Times 9 out of 14. Oh, let's turn this into a percent. Somebody run 6 times 9 for me up top, would you? 54. I'm not very good at math. I think my North Highway 3 math skills tell me that 15 times 14 is 210, though.
Yep.
I can't read that.
Can't read what?
These are little
Somebody take 54 divided by 210 for me and give it to me to 3 places. Yep. 0.257.
25.7%.
It's approximately 0.257. So the probability that this happens right here is about what, kids?
25-ish.
25.7%. Okay. Kids, I want to back up here. How many people were standing up here to be chosen from in the beginning? 6 men, 9 women. Okay. The first thing that we wanted to have happen was a chairperson chosen out of those 15 was a what? How many were men? Do you understand the 6 out of 15 thing? Why is this not 9 out of 15 over here? One person left. One guy left, meaning our total went down to how many to choose for in that second part? 14. And of the 14 that were still left, how many were still women? Okay, does that make sense?
Yes.
All right, let's roll on. So comparing independent and dependent events. When does stuff depend on things and when are they free of each other? A bag contains 10 red marbles and 5 blue marbles. Okay. You randomly select 3 marbles from the bag. What is the probability that all 3 marbles are blue when A, what's happening here, kids?
You replace each marble.
And B, you...
Do not replace each marble before selecting the next one.
Okay, so event A, event B, which one's independent?
B's independent because you don't replace it.
A is going to be independent because every single time you would have the same
Same.
probability. You're choosing from the same sample space every single time, right? But if I do not replace, it's just like walking over to these numbers again, kids. If I pick a number, what's the probability I pick a number here? 1 out of what? 6. If I put it back and I walk up and say, what's the probability of picking that number again? 1 out of 6. And I keep replacing it. My probability or my sample space, does it ever change? No. But if I say, okay, I'm taking this one because I'm the Grinch, and I come back and say, try to draw that number again, you would say, well, I don't know if you're going to draw that number again because it depends on what happened. You did not replace what you already took. Did the sample space, how many pieces are in this sample space right here, kids, to start? 6. But when I make that second one without replacing, how many are in that sample space now? Is the sample space the same or different? Different. And when it's different, it depends on what already happened there, okay? So let's take a look at this. It says, what is the probability that all 3 marbles are blue? Well, how many total marbles are in there, kids? 15. How many are blue of the 15?
5.
So that first draw in event A, I'm going to write down the probability of 3 blues here. That's going to equal, what's 5 out of 15 reduced to, kids? 1 over 3, right? 1 over 3. Okay.
That's so easy.
So it'll be 1/3. So probability I get a blue on the first draw is what? Okay, I'm going to put that blue back in the bag. Sample space the same or different? Same. So what's the probability on the second one that I draw blue? 1/3 again. So 1/3 times 1/3. Put that blue one back in there. And I say, on that third draw, kids, what's the probability that you draw blue? Give me 1/3, right?
So it's 127.
So it's going to be a 1 in 27 chance, right?
Yes, sir.
So the probability of 3 blues, given that the event A is what kind of event? Independent. Because the sample space, you were drawing from the same exact set of marbles each time. This turned out to be 1/27th. Somebody turn 1/27th into a percent for me.
I feel like that's something.
3.7.
3.7%. Make sure I agree with you there. Yep, I agree. 3.7%.
Where'd he go?
Hey, can we all agree right now when we do notes, we'll just round to the nearest 10th right now? I don't know what your assignments are going to ask you to do, but can we all agree right now nearest 10th is okay? All right. Now, what's the difference in part B?
You don't replace it.
If I pull the blue one out,
Changes.
am I putting it back in on the next draw? Okay, so let's talk real quickly. The probability that we draw 3 blues without replacing them is what kind of an event, first of all, in event B? It's dependent, okay? The next draw depends upon, the probability of the next draw happening depends upon what's already happened. Okay, so let's go. Probability of 3 blues given no replacement. Here we go. Guys, to start, how many marbles are in the bag? 15. Of those 15 to start with, how many are blue? So I've got a 5 and 15 chance to start with, don't I? Let's turn that 5 and 15 into what? Okay. And you know what? I'm going to write it as 5 to 15. I'll write it as 1/3 here in a bit. Now, you took a blue one out, kids. How many marbles are in there total?
14 now.
Of which the 14, how many are blue?
4.
So you're going to go times what over what now? Now, on that third draw, am I replacing anything yet?
No.
So when I reach in there a third time, how many marbles still remain? 13, of which how many of the 13 remaining would still be blue?
3.
Right? Oh, let's make this a little easier on us. 5 over 15, that would reduce to 1/3, wouldn't it, kids? By the way, which one do you think is going to have a better chance of happening? The one where we replace them or the one where we don't?
The one right to replace it.
Let's see. This reduces to 1/3. How about 4 over 14? Won't that reduce to 2 over 7, kids? And 3 over 13 doesn't reduce, but, hey, help me out. Wouldn't the 3's cancel here and here on the top and the bottom? What's 1 times 2 up top? 2, right? 7 times 13 on the bottom, I know that's 91. Somebody run 2 divided by 91 for me.
2.192%.
So about 2.2% for this one?
Yeah.
Exactly what we expected, right? We thought we'd have better probability of winning when we replaced as opposed to when we were not replacing, okay? Why is the first one an independent event? Because every time I reach into the bag, I have the same exact chances of getting the same, I have the same exact chances because what's in the bag is always the same every draw, right? Why is the second one dependent? Well, yeah, if I pull one out, so the very first draw is, do I have the same choices in the second draw as I do in the first draw if I don't replace stuff? No. Okay, your sample spaces are different, all right? Questions so far? Are you with me? All right, let's move on this. Using a table to find conditional probabilities. Okay, it says a quality control inspector checks for defective parts. It says the defective parts are shown in the table given the results of the inspector's work. Okay, how many parts are defective here, guys? 29. How many are non-defective? Okay, how many end up passing inspector's work? 213. How many end up failing?
33.
Okay, so it says right here, kids, it says find the probability that what kind of a part? Defective part does what? Okay, first of all, the part has to be what? Has to be defective. Okay. Well, how many parts were defective, kids?
5.
Ah,
You gotta add the
29.
29.
there's 5 defective parts that passed and 24 that failed. So how many total defective parts are there?
29.
Yep. So I'm going to write this down. Well, there's 29. Whoops. There's 29. Come on. 29 total defective parts. Of those 29 total defective, how many passed?
5.
So we would say 5 out of what, kids? Okay, somebody run 5 out of 29 and let's approximate a percent on that.
Everyone else does go fast, or did
17.2%.
17%?
17%? Did I hear 17.2?
No.
Okay. Okay, so you guys try the next one on your own. It says find the probability that, first of all, the part has to be what kind of part, kids? Non-defective. Okay, part's non-defective. What's the percent that it passes? Okay. How many total non-defectives do you have? 217. And of the total 217 non-defectives, how many made it through? 208 out of what?
95.852535%.
So about 95.9%. And it makes sense, kids. If parts are non-defective, they should get through. Sometimes people just don't do their job and they pull a few out. And it makes sense in the other one. If parts are defective, sometimes bad parts get through. They call them Fords, right?
No, come on.
That's very mean. That's what I drive to school every day.
So do I. The steering might shake a little bit, but
Yeah.
still gets you there.
Have you heard that? That tilt steering on his truck's
It
broken,
goes-
so whenever
it
you
even goes left and right.
You're getting like a virtual reality there. It's like Mario Kart. I'm moving, but I'm all over the place.
It's like if you slam on your brakes for a year and then your steering goes.
All right. One last example. Hey, any questions so far? Any questions for me right now so far? Okay, last example here, guys. This is really an important example. Kids struggle with this. It's really pretty simple, but kids struggle with this all the time. Here's the situation. I'm going to put a star by this example because I think it's important. You might want to do the same. Finding a conditional probability. Conditional probabilities are probabilities that happen given something else is happening. So let's talk about this. I need a volunteer to read example 7 for me. Okay.
At a clothing store, 75% of the customers buy pants, only 20% of the customers buy pants and a belt. What is the probability that a customer who buys pants also buys a belt?
Okay, here's the deal. 75% buy what?
Where's the other
Pants.
5%?
And then it says only 20% buy what and what? 20% buy pants and a belt. But here's the deal.
Wait, it's a 5%.
If we're talking about that 20% of people, they bought what and what? Pants and a belt. Okay? They want to know what is the probability that a customer who did what? Buys pants,
So it's a
also got what?
belt.
Okay, well here's the situation. What percent of people, first of all, bought pants?
20.
Okay.
20% buy pants.
If they don't buy pants, are we even worried about these people? No, because we want them to have not one item, but what? So in order for them to get that belt in this situation, they would have already had to have purchased pants. What percent of people purchased pants already? 75. So basically what we're saying is this. What's the ratio of the 20%
20 divided by 7.
that purchased out of the 75%? It simply becomes this. It's basically saying it's the probability of B given A divided by the probability of A. Okay? So the probability of A is like what percent bought pants. And then the probability of B given A is the probability of people who already bought pants, what percent purchased a belt, right? Okay? So it's very simple right here. So the probability of B getting a belt given they already had pants was what percent, kids? 20%, right? And then down here, what was the probability of A happening? Buying just pants.
26.6%.
So 26.6% of people did what? They got both. Got both.
That's pretty good.
That
Most
is.
people walk into your store, one of them buys the.
My question is, where's the other 5%?
Yeah, is that the stolen merchandise?
Those are the people that just walk through the store to get to the store that's on the other
We
side.
got shoplifters too.
Right.
So.
Or those are the people that walk in the store just to use the bathroom.
But now, hang on a second, though. This is saying the following. This is saying only 20%. So if there was 100 people here, this is 100 people here.
Yeah,
How many people purchased pants?
75.
75%. And then of those 75%, only 20 of them went on to purchase the belts. So
then 5%
everybody.
died in that?
What's that?
5% died in that?
They live
Something like that. I don't know.
No, they just go in there and use the bathroom.
Sure, they not buy anything.
All right. I've never heard of a pants and belts, but hey, that's okay. Okay, what I'm going to do here quickly, I'm going to send out a new online. My first question before I send this out, is everybody hooked up into the online stuff right now? Okay, let me back up here real quickly. 5.1 stuff, when does that due? Tomorrow. So your turn to practicing. Don't forget to have the online done for tomorrow. I'm gonna send out the new online, and we'll move on this stuff. Okay? Makes sense.
Do 10 or something because less practice.
I don't usually pull them in until the next morning anyway, so you technically have that. Okay, I think I'm gonna say like 28 or something like that.
What?
When's that? Is that close?
In about 5 minutes, I think.
Fine.